Okay, number 10, there's a boat that has a 4-hour supply of gasoline. How far from the marina can it travel if the rate going out against the current is 20 miles an hour and the rate coming back with the current is 30 miles per hour? Okay, so let's make our table. Distance equals rate times time. And make our rows and columns. And we have against the current and with the current. Okay, so in this case, the maximum that the person can go out is for 4 hours, right? So it says, how far from the marina can it travel if the rate going out against the current is 20 miles an hour and coming back is 30 miles? So they're giving us the combined rate, the speed of the boat in still water plus the current and against the current. So if going out against the current, that's the top row, it's 20 miles an hour is the rate, and coming back is 30 miles an hour. Now we know for a round trip the distance is going to be the same. So the total time, right, the total time equals 4 hours. So if we spend T amount of time going out against the current, so let's say we went an hour against the current out, coming back we have 3 hours. If we went out for 2 hours, then coming back we have 2 hours. If we went out for 3 hours, then coming back we have 1 hour, right? Because the total time is 4. So this one is the amount coming back is 4 hours minus however much time we spent going out, right? So our two equations are the rows, right? So we have D equals 20 times T for the first row, and the second row we have D equals 30 times 4 minus T, right? So there's our two equations. We can simplify, right? D equals 20T, and D equals, we'll distribute in 30 times 4 is 120 minus 30T, right? We distribute that in. Okay, now I have two equations, and they're nicely set up for equal value methods. So these two right-hand sides equal each other, right? So we have 20T equals 120 minus 30T. So we add 30T to both sides, so we get 50T equals 120, right? And we divide both sides by 50, right? So we get T equals 120 over 50. So we could write that as 12 fifths, right? 120 over 50. We could put 12 fifths, right? Or we could write it as T equals 2.4, right? And then let's see first what they want us to figure out, and then we'll decide whether we change that into hours and minutes. So it says, how far from the marina can it travel? Okay, so they're only asking us for D. So we need to take one of these equations because the distance is going to be the same. So I'll take this equation. And we get that the distance equals 20 times T. So I think it's easiest to put it in as the fraction, right? 12 fifths. So the distance comes out to be 48, right? So we would write our answer for this one. It says, how far from the marina can it travel? And it can travel 48, miles, right? So it can travel 48 miles out and then 48 miles back.